So let's begin with linear regression. So in supervised machine learning, we have a data set D, which is a set of point xi and yi, where I goes from 1 to m. That is, we have m data points xi and yi, where each of these xi's is a real vector. Or more specifically, each of these xi is an n-dimensional real vector, and each of these yi is a scalar. So the goal of supervised machine learning is to learn a functional mapping that explains the data. That is, the goal is to learn a function f, which is parameterized by some learnable parameter w, that takes in the xi and produces corresponding value yi. Or more specifically, f is a mapping that is parameterized by some learnable parameter w. F is a mapping from x to y. That is, it maps an n-dimensional real vector to a scalar for all the vectors that are drawn from the same distribution from which the data set is drawn. So let's assume that the data set is drawn from some probability distribution P. So for any vector, any real vector that is drawn from this distribution P, we can produce a scalar value, its corresponding scalar value, using this function. So you may ask why we do this, right? If we already have all these xi's and yi's, we know their corresponding value. So why do we need to learn specifically this functional mapping f? So let's consider a case where you see a variable x hat, which is not in the data set, right? And you want to guess its corresponding value y hat. Right? So what can we do in this case? So assume that this x hat is drawn from the same distribution, that is, x hat is drawn from the distribution P from which the data set D is drawn. So in this case, if we have learned this functional mapping f, we can just plug in this x hat into the function and we can get its corresponding value y hat, where x hat belongs to same distribution. Or more simply, we can just plug in the x hat and we can get the corresponding y hat value. So this is what we do in supervised machine learning. We take a data set D, we learn a functional mapping, and for any new variable x hat, which is drawn from the same distribution from which the data set is drawn, we can produce a corresponding y hat. But to get a better understanding as to what is actually going on, actually what we are doing, let's consider a very simple example. So assume that we have a data set which looks something. So this is x-axis and this is y-axis. So assume that we have a bunch of data points, that is m data points. Right. And for each of these points in the data, we have a corresponding value y. Right. So we can compute a function that best explains this data, right, or best fits this data with respect to some cost function, and we'll learn what cost functions are and how to compute this functional mapping. So let's assume for now that we can actually compute such a function that explains this data or that best fits the data given some cost function. So let's assume that this is that functional mapping. This red line, we are just drawing a line, we are just drawing a curve or a function that we think best explains this data according to perhaps some cost function. So let's assume that this is our functional mapping. So for each of the values xi in the data set, we have a corresponding value yi. Likewise, for any other point xj, we have the corresponding value yj. And we learn this functional mapping, this red color function, using this data set. But what if a new point x hat arrives? So let's assume that this is our new x hat, and you want to get its corresponding value y hat. So you may ask, how do we do this, right? So if we have learned this function representation that best explains the data set, and if this x hat is drawn from the same distribution P from which the data set D is drawn, that is, this function explains the data set which is drawn from the distribution, and if x hat belongs to the same distribution, then we can just project this on the function. And using this function that we have learned from the data, we can get its corresponding value y hat. So as you can see, what we are doing over here, we started with a data set. We computed a functional mapping f that best explains this data, and then whenever a new point x hat arrives, we just plug it into this function f, and we can get the corresponding value y hat using this function. Here also in this pictorial depiction, we are doing the same thing. We started with some data points. We learned this functional mapping that best explains this data, and whenever a new point x hat arrives, which is drawn from the same distribution from which the data set is derived, we can just use the learned functional mapping to get the corresponding y hat values. So this is what supervised machine learning is all about. You're always given some data set from which we learn a functional mapping that best explains this data set, and whenever a new data point arrives, which is from the same distribution from which the data set is derived, we can just compute its corresponding value using the function that we learn. So each of these, to give you a better understanding, each of these each of these data points can, let's say, represent an obstacle in an image. Let's suppose you are doing autonomous driving and your goal is to predict the corresponding depth of the obstacles in the images. So each of these data points represents an obstacle in an image with different configuration, with different geometry, and each of these yi, let's assume, explains or predicts the depth of the particular obstacle in that image. So whenever, let's suppose you have learned this functional mapping that learns to predict the depth of obstacles in an image. Whenever you are given a new image, let's suppose you are building your own autonomous driving vehicle and you want to now test a function that gives you the depth of obstacles in the images, then you can just learn, use this learned representation that maps obstacles to depth. And while you're doing autonomous driving, you can use the same function and it will compute the depth of every obstacle in your images. So this is a very simple example of what supervised learning is all about. And later on in this lecture, we'll learn the cost function. We'll also learn a simple algorithm known as linear regression that allows us to do this.